Okay, well, thank you everyone for joining us today. We have an action-packed meeting for you all. To get started, or I'll go over our agenda first. Um, First thing is going to be doing roll call. Then we're going to have a presentation by Karen Drozdiak. Did I say that right? Um,
Good.
from First Solar. Then we're going to have kind of a joint presentation from Pablo Diaz with Solar Cycle, and then Kip Frey with HG Ventures, which I believe is an investor in the new in the recent Solar Cycle operation. And then at the end of this meeting, we are going to uh, uh, continue the policy discussion that we started in our last group. So for folks, um, for reference, I put what is in the law and what we have to recommend in this particular report to the General Assembly. Just so you all know, we're still planning on meeting um, in the coming year, and hopefully we'll be able to provide some robust recommendations that have consensus at the MCC fee meeting next October before session. So then I did want to let everyone know that I scheduled a follow-up meeting to finalize any recommendations that we don't get to on what is that, October 31st. And then on, hold on, I'm just going to find it on my calendar. I believe it was, I don't, oh, I see it. On the 18th, November 18th, we are going to be doing the final report out from the university and Johns Hopkins on the report. So any questions on that before I go into um, roll call? Cool. Without further ado, let's get right into roll call. So Senator Benjamin Brooks, Delegate Mike Rogers,
Here, present, accounted for.
Tyler Abbott. I don't think Tyler Abbott's here, but I am standing in for him. Evie Schwartz,
Here, present.
Josh Kurtz or his designee. David Chai,
Present.
Diana Menendez, Pearl Donahue Valet, David Bugelman,
Here.
Stacy Ono,
Right now,
Stacy's here. Thank you.
and then Scott Elias.
I'm here. Pearl recently switched jobs. I don't know if that impacts whether she's part of this or not. If we get a flag for you.
Oh, okay. We will have to figure that out for next year.
Got it. Yeah, she's with FERC now, so I would imagine she's probably not gonna participate in this.
I think I did hear something about that. But we'll have to find someone for that. Okay. All right. So without further ado, we will get right into our first presentation. Karen, I'll let you take over the screen.
Wonderful. Thank you so much. All right. Hopefully this works. All right. Are you able to see the full screen?
It's not in presentation mode. It's in editor mode
okay.
right now.
Hold on. Is that better?
I'm still seeing the same thing. That,
Not sure if this. Does this work at all?
we're still seeing editor mode right now.
Unless you have some motions going on, that's fine. You can see the slide well.
Yeah, we can see the slide if you just want to move through it.
Yeah. I mean, I also have it in PDF format if that helps anything, although I suspect it'll be the same. So I might just try this. Is it still doing the same thing?
Yeah, it's still in editor mode, which is
Okay.
fine. We can see the slide if you want
All
to run
right.
through it.
Yeah, I'm sorry. I'm really sorry about that. Google Meet is not good to me. So thank you all for having me. My name is Karen Josdiak, and I lead global ESG and sustainability for First Solar. And a little bit about First Solar. We are the largest American solar manufacturer. We were founded 25 years ago. We aim to have 25 gigawatts of manufacturing capacity by 2026 and 14 gigawatts of that here in the US. We manufacture in Ohio, now also in Alabama, and soon also in Louisiana. And we manufacture thin film cadmium telluride solar panels, which are manufactured through a vertically integrated manufacturing process. So a sheet of glass goes in, about 4 hours later, a completed solar module comes out, and that results in the lowest carbon footprint in the industry. We also established the industry's first global recycling program back in 2005. So I'll share a little bit about that today. So a little bit about First Solar's approach to circularity. Oftentimes when we think about circularity, we're talking about end of life and waste, and we've integrated circularity across the product life cycle. Starting at the very beginning, we take byproducts from the zinc and copper mining industry, turn that into a stable cadmium telluride semiconductor material, which is ideal for high volume and resource efficient manufacturing. And that results in solar panels that have a carbon footprint that's up to 4 times lower than panels manufactured in China or other carbon intensive grids. And then at end of life, through our high value recycling services, we're able to recover more than 90% of the materials in a solar module.
Karen,
Yes.
sorry to interrupt you, but because I've seen this presentation before, you're not changing the slides that we're seeing. You're still on the first page, and I know that you're ahead. You're changing the other link to the screen.
Yes. Thank you, Pablo. Thanks for flagging that.
If you go out of your presentation mode and just into the normal deck, and you change those as you go, that's
Yeah. Let's see.
You can also email it to me as well.
Okay. You should have it. I sent it to you and Stephanie earlier today.
I see. Okay.
Let me see if this.
Okay. Well, you have it right there.
Okay. I'm gonna try to figure out the best way to move it, but hopefully, let me know if this changes. So, are you able to see embedding circularity across the life cycle?
Yep.
Okay. All right. So this was the slide that I was actually speaking to. Thank you, Pablo, showing how we've embedded circularity across the life cycle and recover more than 90% of the materials at end of life. Next up, highlighting our industry-leading PV recycling services. So as I mentioned, we established the industry's first global recycling program back in 2005, and we've recycled about 400,000 metric tons of solar modules to date. We operate these facilities here in the US and Ohio, now also in Alabama, Vietnam, Malaysia, Germany, and India. And so we achieve closed loop semiconductor recovery. So we're able to recover the cadmium telluride semiconductor and reuse it in new solar modules. And we're continuously focused on driving down the cost of that to make recycling a no-brainer at end of life. Our recycling facilities are also scalable to be able to meet end of life needs as more solar modules come back from the field. Today, a lot of what we're recycling is manufacturing scrap because solar modules have a lifetime of more than 25 years, if not more than 30 years now. All right, next up, hopefully you can see this slide on our recycling services. Just to confirm that.
Yeah,
You're
Karen,
good to go.
Okay, good. All right. So we offer global recycling services to our customers. The 2-year terms of the recycling services help customers benefit from any cost reductions that we're able to achieve as we continue to refine our technology. We also initially started with a pre-funded recycling program back in 2005, where the cost of recycling was included at the time of sale. But we quickly realized that when this is something that works for products that have a short lifetime, small electronics, but when you're talking about a product that lasts for more than 30 years in the field, it makes a lot more sense to pay for recycling closer to end of life. And so that's why we offer a pay-as-you-go approach where later year project cash flows can be used to help pay for recycling at end of life. And of course, it's scalable to help meet future recycling needs. This is an overview of First Solar's module recycling process. So this actually includes 4 generations of the recycling technologies. We're now in our 4th generation here in the US. And so the first step is a mechanical crushing step. So the modules are broken into small pieces to help separate the glass from the laminate material. A leaching process, so a chemical leaching process is the second step to help extract the metals from the glass and semiconductor material and laminate material. Those metals are precipitated, then sent to a third party for refining. It comes back to us as CAD-TEL, which we can then use in new solar modules. The glass is cleaned and used in glass container products. And in Malaysia, the laminate material is used in rubber products like shoe soles and bike handles. And so a question we get sometimes is, more than 90% is great, but why not 100%? And the 5 to 10% that can't be recovered consist of glass fines that are created through this mechanical crushing process. And so those are absorbed by high efficiency filtration systems. Next up, this is just showing how our recycling process has evolved from initially a batch process to a continuous flow process, which enables us to increase our recycling capacities, achieve greater leaching efficiency with fewer chemicals and less waste, and maximize material recovery at end of life, as well as the value of the material, which is an important part of bringing down the cost of recycling. So we recognize that high value recycling is important for all solar technologies, and we're partnering with the Remade Institute, national labs, and other universities across the US to pilot high value recycling technologies for crystalline silicon modules. We're also trying to figure out how to close the loop on other materials like glass and aluminum, like we've already done, excuse me, for our semiconductor material, and help ensure that it's not just going to glass container products, but coming back into the solar supply chain. We're also looking at working with universities that are looking at innovative delamination processes, which again help to maximize material recovery as well as the value of the materials recovered at end of life. And so a little bit about why does high value recycling matter? About more than 1.5 terawatts of solar PV have already been installed worldwide, and environmentally sensitive materials are common in the industry. Albeit, these are trace materials, and so it represents roughly less than 0.1% or around 0.1% by weight of the product. And the value of high value recycling is that it helps to minimize the life cycle impacts of solar modules, create jobs in the process, but also maximize the material value that can be recovered. And so there's a study which you may have come across by the International Renewable Energy Agency and the IEA PV Power Systems Program, which found that the recoverable value of solar modules could exceed 15 billion by 2050. Next, I just want to walk through a short history of PV recycling. So back in 2005, we established the first global recycling program. In 2007, the European Union conducted a study on the importance of recycling for the solar industry and found that recycling was important for all solar technologies. A voluntary industry approach was attempted through PV Cycle back in the day. However, it dealt with the inevitable free rider challenge where some companies were paying, others were not. So in 2012, the European Union decided to mandate solar recycling through the Waste in Electronic and Electrical Equipment, or WEEE directive. In 2016, the U.S. Solar Energy Industries Association established the PV recycling program, which makes it easier for customers and end users to identify recyclers and refurbishers and recyclers that actually recycle. So there are some recyclers that may not, in fact, be recycling. Then in 2017, the Senelec standards creation body in Europe developed high-value recycling treatment standards to help guide waste operators on how to extract and materials from solar modules and ensure the cleanliness of the byproducts that are created. And in the 2020s, we saw the publication of sustainability leadership standards like NSF 457, which the EPEAT Eco Labels PV module and inverter category is currently based on, as well as the R2 responsible recycling standard. So moving on to touch on the EPEAT Eco Label for solar. So this was created back in 2020. It's a globally recognized and independently validated eco label, which addresses the entire life cycle of the solar product. And that includes recycling, such as recycled content in the product. It requires companies that register their products in EPEAT to have an end-of-life program that they offer to their customers, whether it's through an in-house program like we do at First Solar, or through contracts with recyclers. And then last but not least, design for recycling, ensuring that the manufacturer is providing information on the composition by weight of the product to help enable recycling at end of life. Earlier this year, they also introduced ultra low carbon solar criteria, as well as low carbon solar criteria to help make it easier for purchasers to identify environmentally leading products. And so we're excited to be the industry's first EPEAT Climate Plus champion. The other important thing to note about EPEAT is that it is the only recognized eco-label by the US EPA for solar modules and solar power purchase agreements for the use of public procurement. And just to keep moving, so next up, I did want to address some common misconceptions that are out there, specifically around the fact that some people think that our CAD/TEL technology requires different end-of-life management requirements, and that is not the case. There's a study that was published by the IEA PV Power Systems program, which looked at worst case in the event of improper disposal for crystalline silicon solar panels, cadmium telluride solar panels, as well as CIGS PV solar modules. And they found in all cases, assuming, and this is looking at a 100 megawatt utility scale project, assuming a total release of the material of the metals into the rain, then into the soil, that those would be well below human health screening levels, as well as the EPA's maximum contaminant level in drinking water. It also shows how the end-of-life impacts for cadmium telluride solar panels are comparable to, if not lower than, crystalline silicon panels. Next up, I further want to highlight and address the misconceptions about, which technologies are toxic, which ones are not. The reality is you cannot make a determination on whether a solar panel is hazardous or non-hazardous based on technology. You need to conduct TCLP testing based on the toxicity characteristics leaching procedure. One of the concerns around TCLP testing is that different methodologies and it can result in different results. And so there was a need to standardize it. And so ASTM developed a standard precisely for that, to establish a repeatable sample preparation process to help ensure a more repeatable testing. And last but not least, some of our key lessons learned is that high-value recycling is important for all PV technologies. Not all recycling is created equal. Most of the recycling that we see occurring today focuses on recovering mass fractions like the glass and the frame, but it's important to go further and also recover the semiconductor material and other metals. Waste characterization cannot be determined based on technology, manufacturing date, or the age of the panels. Pay-as-you-go is definitely a more cost-effective approach when you're dealing with a product that has a long lifetime. One of the key barriers to help address is making it easier to facilitate the transportation across state lines to recycling facilities. There has been also interest in in-state recycling by different states. It's important to allow recycling, also out-of-state recycling, because that helps to ensure more competition and essentially lower costs for the end users at end of life. And then last but not least, it's important to go beyond mass-based material recovery targets and encourage high-value recycling through eco-labels and other standards. Thank you very much.
Yeah, so thank you for that presentation. So we're going to be talking about policy in the state of Maryland. And I mean, some of these go to policy as well, but what being in the recycling, or you're more in the reverse logistics and you're trying to get your product back, right? So that you can reintegrate it into the into future products.
We're not in the reversal logistics. We're actually doing the recycling, and we're manufacturing the product. And reverse logistics is also one of the key challenges, making sure that products come back to recyclers, to manufacturers for recycling and processing.
So what are some of the things that you would want to see states that are considering policy moving forward? Things that would help you.
So things that would help is, ensuring that, regardless of the state of the panels, that, if the recycler is ready and able to accept them and is able to treat them, then they should be able to be sent to the recycler.
All right. Do we have any other questions from the audience?
Bradley, I have one question. This is Bob Nicholson with the Solar Energy Industry Association. Karen, thank you for the presentation. By the way, very well done. My question is, and I'm sorry if I missed it, Karen, is First Solar receiving broken panels at this point for recycling as well?
Yes. So the only challenge, what we cannot recycle is something that includes mixed debris, but if they're broken, that's fine. They can be recycled.
This is Scott Elias, Green Capital. I have a question as well. How does First Solar view extended producer responsibility policy models? I know that's a bit controversial within the industry, but it's something that Washington State has looked at, and so I'm curious if you have any lessons learned about extended producer responsibility that we should keep in mind for Maryland.
Absolutely. I think Washington State is a good example of why EPR does not work for our industry, and it's because we have products that last for more than 30 years. It's also difficult to enforce, especially with foreign manufacturers, and so it would inevitably result in burdening domestic manufacturers. Also, the other important key learning that we had is that when you're selling to utilities and independent power producers who have experience with decommissioning, it makes a lot more sense to allow for contractual decisions to be made around recycling, as opposed to mandating that the recycler or that the manufacturer pays for it. The other key difference between our products and, say, paint or other materials is that it generates revenue throughout its lifetime. So it makes a lot more sense to pay for recycling closer to end of life.
Just follow up on that. Is that for residential and utility scale solar, or just utility?
So we only sell to the utility scale sector. I defer to Bob and others for views on how best to manage it at the residential level. I think that's a little bit trickier.
And then I think David had if someone has a comment on that, and then David Comas had a question after that.
No,
All
this is David. I was going to ask about residential, but you just said they don't sell to residential, so my question was mute.
I think that's the conundrum that we're in. There are robust end of life systems, even in the state of Maryland, for utility scale, but it's definitely a harder nut to crack at the residential level. David, did you have something that you wanted to add to that?
No, that was my question. Thank you.
Okay, all right. Any other questions for? Oh, Shannon.
Yeah, hi Karen. Thank you so much for the presentation. That was really helpful. I'm just curious, you mentioned where you're located throughout the country. Where would you say this is the best way that we could capitalize on bringing those materials to those southern states and those western states from the East Coast? Because you didn't really mention any East Coast operation. And so I was just trying to figure out what the logistics associated with that would be and how to maximize on that opportunity.
That's a good question. I guess the closest would probably be our Alabama facility. The other option is our Ohio facility, which is in northern Ohio, close to Toledo. So I think recycling costs will vary depending on how far away the project site is from the recycling facilities.
And can I follow up with that and just ask, have you thought about expanding somewhere within the Northeast region or the very southeast?
So we are, thinking about long-term expansion, and a lot of it depends on, where are the large volumes of modules going to be reaching end of life soonest. And when you think about the US, a large portion of the early solar was installed over on the West Coast. Not so much in the Northeast, unfortunately.
Yeah, and I guess this is my final question. So have you considered any sort of modular processing operations that could occur to handle that like spike across the Northeast or the eastern part of the US, but wouldn't necessarily have to be a permanent operation long term?
Yeah, good question. So we I mentioned we're on our 4th generation recycling technology. We've also thought about, okay, what's the next thing? Modular recycling facilities, which can be located close to, large utility scale projects, is an option. But we haven't made any decisions yet on that front. But that is something that's possible.
Thank you.
And then one more question, and then we'll have to move on. And if you have other questions, you can certainly send them through me. You can put them in the chat or contact Karen directly. Cool. Without further ado, I will turn it over to Solar Cycle and HC Ventures for their presentation. Thanks so much, Karen.
Thank you.
All right. Good morning, everyone, or afternoon, depending on where you are. Kip from HC Ventures was trying to log in. He said he waited for 15 minutes on the waiting room and then logged off. So I'm not sure if anybody has control over that. You can check. I told him to try again like 2 minutes ago. So I'm not sure who's
I haven't seen anything on my end for that.
All right. So just flagging that to me. He might be able to join later, but if not, then he's not gonna be joining us. I should be able to share my screen. It doesn't want me to share my screen. Let's see. Try again. Can you guys see my screen?
Yeah, you're all good.
Beautiful. All right. So glad to kick this off. And like I said, my final slide is actually introducing Kip. I'm not sure if he's going to make it or not. If he does, then great. If not, we can have more time for discussion. This is a presentation that I've been giving around the idea of what a circular economy for solar could look like. This is the whole vision around Solar Cycle, why we created this company. Solar Cycle is a solar startup. We started in 2022. That's launched in January. So we're almost 3 years old. but not even that old as of yet. Our whole idea is to be a circular economy company and to be able to make best use of end-of-life panels, make best use of the materials, and really create that circular market as opposed to just being the recycler. We're founded by people from the solar industry. There's 3 co-founders. Our CEO, Suvi, has had a solar manufacturer that went public, has operated that for over 20 years. So not a lot of knowledge for the solar market. Our second co-founder is Jesse, who's worked at the Sierra Club for over 10 years with grassroots advocacy around renewable energies. And myself as the third co-founder, I've been working with solar recycling research for over a decade as well, pulling panels apart and learning how to best do that process. So we come with a lot of knowledge from the solar space. We're trying to construct and build the circular economy for solar that really can be an example for other places, not just for solar, for the solar industry. But we believe today there is a special, we're in a special time and place in which there's a lot of factors allowing us to create something very special. And that's what I want to talk to you guys about. So these factors, let me see if I can go forward with my screen. There you go. So these factors are on the screen. There's basically 5 of them. I'm going to talk about each of them one by one. This is generally a longer presentation that I've condensed for our day today. But we're going to talk about building more solar that we need and how that requires resources, about the negative use of media, about the off-taker market, the learning rates for solar and recycling advancements. So starting on the left with the infrastructure. We're here and we're talking about this, and solar is so important because we ought to achieve net zero. Net zero is one of the key milestones that we need to be able to fight climate change. And we're already with significant global warming that we're already measuring and seeing consequences of, unfortunately. And net zero is a key to be able to combat that. But achieving net zero sometimes is hard to grasp because the sheer amount of renewable energy, or sheer amount of energy that we require in the world today is very hard to understand and to put into our heads. But just to give you an idea, today, worldwide, we have about 1.5, 1.6 terawatts of solar installed. All right, and this has been a tremendous growth. Solar is one of the leading energies today in the world. And that's just the tip of the iceberg. To be able to achieve net zero by 2050, we need 15, right? So 10x what we have today, terawatts installed on the most conservative estimates, all the way to 60 terawatts plus on some estimates that are more focused on the solar industry. So the IEA's projection is out of 15 terawatts. Again, 10x of what we have today in the world. So significant increase in what we have already installed, all the way to 60, right? We're talking about, 40, sometimes 40 plus growth in some estimates. So that's all to say that we need way more solar than we already have, and way more solar requires more resources, right? So it's not like solar panels are made out of thin air. We need, aluminum, we need silver, we need silicon, we need glass, and those all are resources that we need to extract. And if we need to deploy so much solar, we need significant amount of resources. These resources, the estimate that we have for resources, to give you guys some ideas, for silver, if we continue on the same trajectory you are now, the solar industry is going to consume all the silver available in the world by 2050. That's how much we would need. The other one is, another example is the aluminum, because if we continue in the trajectory and we actually achieve net zero, the solar industry will basically consume 40% of all the aluminum that we produce today. Aluminum is a huge market, right? Aluminum is used in airplanes, it's used in cars, it's used in construction, it's used in electronics. And if solar were to consume 40% of that, we'll be on a shortage of aluminum. And this is not it's not a doom and gloom kind of scenario. We can, and we've seen ways to do it, but it is just to show that we need significant resources. And these resources, they have their own impact as we mine them off the ground and we collect them, right? So as we extract more and more off the ground, the resources become scarcer and scarcer. So that's the first point right now. We need way more resources to be able to achieve net zero, to be able to deploy more solar. Just to give you an idea, we have about 3 billion solar panels in the world today. We need anywhere from 34 to 140 billion solar panels. Okay, so this is easier to actually contextualize and grasp the numbers. In the next 12 months, we're likely going to have more solar panels in the world than we have people. That's another way to think about this. So we need way more solar. That's the first key point of the confluence of factors that we are in today. Way more solar, and more solar requires more resources. The second point is around the media and how the media sees the solar panel development in the solar industry. So as the solar industry grew, so did the attention of the media. And we've started seeing some new spots like, the dark side of solar, or megatons of toxic waste, or how California went big and now it has a landfill problems. And this has been creating challenges for the deployment of solar that we need, that I just talked about, right? So communities start seeing these headlines, they start getting afraid. Oh, should I have solar in my backyard? Should I have solar in my community? Isn't that going to be a problem for me? And as Karen alluded to in her presentation just before, there's a lot of misconceptions around the topic. And if solar is properly managed at end of life, not only we don't have any issues with any sort of contaminant, but we can also make use of those resources and put them back in the supply chain to reuse them again and create new solar panels, which is the whole idea behind the circular economy. So because this has been growing, this kind of negative views, and these headlines have been showing up more and more, communities have been misinformed often about the dangers of solar, whether they exist or not. So this is the second factor that plays a crucial role when we talk about the circular economy for solar panels. Now I'm going to skip to the right, the bottom right, which is the learning rates, which is something amazing that has happened in the solar industry over years, year over year, due to amazing work of researchers, right? So we've been getting better and better and better at outputting more power, outputting more energy with less material. It's something that we've coined, my team and I coined and we did research in this, the material consumption per unit power, or CPP, which is basically a measurement of how many milligrams of something you consume by how much power wattage you can output, right? So if you lower the amount of mass that you need, the top of that fraction, then you can decrease your CPP. And if you increase the power of the given panel, you can also decrease your CPP. And both things has been happening over year consistently. What I show on the left here is the learning rate for silicon. So all the circles, the blue circles, are the historical ones, and the red triangles are also historical ones, depending on how you look at it. And then after that is the projections that we have for how the learning rates will continue as we scale the industry. So it's consistently been decreasing. These are log graphs, so don't be fooled by the straight line. And it's been amazing, right? This whole industry has been amazing at doing that. Same thing I'm showing for silver on the right. We've been consistently being able to produce more power using less and less silver, right? Which speaks volumes to the resources that we need that I was speaking about in the beginning. There's the same trend for different materials in solar panels. You can look at the glass thickness, it's been decreasing. You can look at other uses for other materials. It's basically a trend in all the fronts. So that's the third reason right there. So the learning rates, right? We've been able to decrease the resources needed per watt, and that has been consistent, and we expect that to continue year over year. And then on the top right, we talk about recycling advancements, which is obviously where a lot of what Solar Cycle does comes in. So solar panels, when we speak about silicon, which is the dominant technology, Karen was speaking about the CAD-cell technology, which is very important here in the U.S. market. It's about 20% of the U.S. market. But the silicon technology, dominates the market here in the U.S. and elsewhere. And the silicon technology is basically broken down for you on the left. Those are the macro components of a solar panel. So you have the aluminum frames, the glass, you have precious metals in the middle, which is where the cell is, and then you generally have plastics or another layer of glass on the end. And we've been getting better and better in all fronts when it comes to end of life. And that's the right part of the chart that I show you, which is basically the collection, right? The reverse logistics that Bradley spoke of when he was asking questions to Karen, but also the pre-processing, the breaking down of these macro components, and the end processing, which is when you really extract these resources and make them ready for the supply chain. That can be either, on Karen's example, the treatment of the CAD-cell that they precipitate and send into an industry. That will be the end processing there when they recoup that CAD-cell to use in a new solar panel. Or it can be, as an example, the silver, that you actually extract the actual silver that can be used to make jewelry, to make new solar panels, or anything that you want with that same silver. And we've been getting better and better, and that's a lot of what Solar Cycle does. Our approach is a vertically integrated approach. We actually do the reverse logistics. We go to the sites, we collect the panels, we bring them back to our recycling facility, we do the pre-processing, we do the end processing. And our whole objective is to be able to increase those rates ever more. And if you combine the factors that I've been speaking of, which are, again, just to refresh you, the building more solar panels because we need to achieve net zero, that requires a lot of resources, the negative view in the media, the recycling advancements in the learning rates, we get to these confluence of factors, which is the key to the presentation. Today at Solar Cycle, we actually compete with basically two types of competition. We have landfill, which is fierce competition because today it's still more costly to recycle a panel than it is to landfill one. So there's still a delta today, and that means that if people want to go with the cheapest option, they will still landfill it. So, stakeholders, they need to want to recycle and need to be able to bear that cost for the time being. And our whole business model is precisely to be able to extract more and more value out of a solar panel so that we can decrease the cost of recycling, obviously through not only economies of scale and lowering the cost of our actual process, but also by getting more resources on the other end. Those two things we try to do to be able to lower the cost of recycling and be able to level that with landfill. Anything that makes landfill more expensive also plays a role and helps with that vision, but it's not something we can control directly. And the other thing that the other players that we compete with are, I put in quotes, recyclers, right? So not actual recyclers, but really sham recyclers. So, our whole vision for this company, the whole idea is to be able to divert panels from landfill and to reuse those resources. So other recyclers are more than welcome. Like we want all the panels to be diverted. We don't want any panel to go to landfill. But we've seen in the industry the prevalence of sham recycling happening, which is basically when you take the panel and you do any sort of process to it and you dump the rest or you landfill the rest with the idea of getting some money for the recycling without having to pay the cost for recycling, which unfortunately is a reality not only in the US, but has been seen in many other places, not only with solar, but also with other end-of-life components like e-waste, for instance. So this is the current scenario that we're dealing with. But like I said, we've been able to get good advancements on the amount of extraction rate that we've gotten. So if we sum up these four factors that we see, and this is today, this is a here and now, this is not, some projection to the future, these all four factors that are happening right now. This is a reality today. We get to this very interesting graph, in my opinion, in which we look into the past and we look into the future, and we use silver here as an example to see, is the circular economy really possible or not? What is the impact of recycling panels? How much impact is that really? So what we do here is we start on the, and I'm not sure if you guys can see my cursor. I'm going to try to highlight some things here with the pen. On the left-hand side, what we're doing is basically we're projecting what's going on into the future. Okay, and what we already know from the past is how much solar has been installed and how much silver has gone into each of those solar panels. We have good data on that. If we take that then and project it into the future, we can see how much silver is going to be available for future solar panels. That's the whole idea of this graph. So to be able to project into the future, we need to know how much solar is going to be needed. So the projections of solar deployment, and we can do that for different scenarios. Here I'm showing you the IEA slow scenario, the 15 terawatts that I mentioned at the beginning of the talk. And in the bottom here is the silver learning rate, which is also something we talked about, the CPP, right? So how much silver I'm going to need per watt produced. And I use these two things to send the projection into the future and to see how relevant silver is going to be in the future. And then I get this really colorful graph, which shows me different curves, different color curves for how long these panels last. So if my panels last only 10 years, which is super aggressive, is not something that we've seen in the field, but it's something that is prone to different factors such as repowering and hailstorms and hurricanes and things that tremendously lower the average lifetime of a panel. We have the 17-year average lifetime of panels, which is something that we do see in the field a lot. So this is, I would say, closer to reality. In the 25 years, which is more related to the warranty that some panels have. They have warranties from 35 now to 40 years sometimes, but the average lifetime ends up being lower because of the early loss scenarios. So these three different shades depend on how long the panels are going to last. And what we're looking at here is, what is the percentage of future PV silver demand that I can meet with the silver and end-of-life panels? In other words, how relevant is recycling for the future of net zero that we're talking about? If I have 100%, and we see that we always cross that 100% threshold in any of these scenarios, that means that all the silver that we need for future solar panels can be achieved or recovered through the recycling. I don't need to extract anything off the ground anymore. I don't need to mine silver once I cross that 100% threshold. And this is super impactful because when we set out to do this research, this was pre-solar cycle, right? This is me in academia as a researcher. We were not sure if the number was going to be 10%, 5, 20. We were thinking it would be something around that kind of magnitude. And we found that actually, if we do this right, if we actually construct the infrastructure and we put everything in place to be able to collect these panels and extract the materials off them, we can cross the magical threshold of 100% at some point. Okay, so this is extremely powerful, extremely powerful. It shows that this is not just theoretical. This can be done. We just need to be prepared for it, and we need to put the the investment and the willpower behind it, which is one of the reasons why we are talking here today. So there's a fifth. So the whole idea, behind solar cycle, the whole vision is, to be able to have a solar recycling industry that end of life panels come to us. We test those panels, so panels can be reused. We can deploy them in a second-hand farm, as you see here behind the factory. That's our whole idea. Now we can redeploy and reuse these panels to their fullest extent. When they break, they're going to be right on site to be recycled again. And once they're recycled, these materials can be used in the industry again. Of course, if we can put them into the solar industry, that's ideal, but it doesn't have to be. As long as they're being used to their full extent, we can create something very meaningful and very powerful. And this has been the vision when we started the company. This is, like I said, 2022, but it's also our reality today. So our reality today is, this is our plant in Texas. We already have 4 lines operating in this plant here. You can see the amount of panels we have already, staged to be processed. It's a significant amount. And what you can see here on the back is our secondhand PV life farm. So this is a secondhand farm that we've deployed. This is the first of its kind in the world, as far as we know it. We've deployed panels from different projects with our partners, with our customers. We're now getting a lot of data about it to see how much we can generate. What's the what's the kind of care we need to take with these panels, because secondhand is not something that's widely studied. What is going to be the power degradation and all those good things. And these are all panels that we've tested on site. We've tested ourselves. We've deployed them ourselves. And again, when they fail, they can just go next door to be recycled. And on the right here, what we have is our second recycling facility in Arizona, where I am right now, which is a factory that's actually dedicated to First Solar panels. We're recycling First Solar panels to help Karen, because their industry is growing a lot. They're booming in their sales, and there's enough demand for recycling that we can help First Solar to meet that. So this is not just our vision. This is also our reality right now, and we're about to open a third facility in Georgia. And this third facility in Georgia is not only a recycling facility, but it also makes value-added products. Because the whole thing around the confluence of factors that we haven't talked about just yet is that bottom part, which is the market, right? The off-taker market. Where do materials go? It's not enough for us to have an amazing recycling process if there's no one to take that material and actually make something with it, right? So we can have the best possible recycling process. We can extract all the materials on its higher purity. If we don't have somebody that can use them, there's no point in doing that. And we see that, a great example of that, with the different materials that I've listed before, right? So the aluminum frame, that's super easy to recycle. There's, like I said, the aluminum market is huge. We send those frames, they're smelted again, and they go to any industry that requires aluminum. That's very easy to do, and that's very circular. On the glass side, I'm going to go back to this and talk more in a second, because this is a key part that I want to talk more about. On the precious metals, right? So we have silicon, we have silver, we have copper, all metals that there's no shortage of off-takers. As soon as we recover those materials, there are a bunch of markets that are willing to take these materials and put them back into the market. They're very valuable. Precious is there for a reason. The plastics is one of our challenges today. The plastics, not all of them are recyclable from a chemical or technical point of view. There are some halogens in there that make it a bit more complicated to do different processing. So this is it's a gap in the market, and we're always been very transparent about this with our customers. This is something that we need to address, not only us as recyclers, but also the industry as they're making their products, to be able to have uses for these plastics. But then going back into the glass, here what I do on the right-hand side is I rank uses for low iron glass. Glass used in solar panels is extremely pure, it's extremely special. It's not just your normal window glass. It actually has to have low iron to be able to allow more sunlight to go through and increase those efficiencies. So the best possible use for a glass that I recycle from a solar panel is to make a new glass from a solar panel. This is a special kind of sand that goes into it, special kind of dolomite, special kind of raw materials that need to be sourced from unique places. So the more I can put back into the solar industry, the better. But I can also I can lower the entropy, if you will, on the scale, or increase the entropy, if you will, on the scale. And I can do any of these things with a solar glass, all the way down to fillers, right? So I can put it as asphalt, for instance. The asphalt is gladly going to take glass. There's no problem if I remove any of the other metals and just use glass. That's totally doable. But I'm taking something of very high quality and putting it into a very low state. And when I do this thing, I'm kind of breaking the whole idea behind the circular economy that we just spoke of. Because of that, Solar Cycle actually is opening this facility in Georgia that we're going to do not only the recycling and not only the secondhand PV farms, but also the manufacturing of glass. There's literally no glass manufacturing for PV rolled glass in the USA, none. So there's no market for it. There's no way for us to sell it. And we've tried very hard to convince other people to do it. Basically, we didn't get a yes, and therefore we decided to do it ourselves. So we're deploying this manufacturing line in Georgia. This is going to be manufactured for rolled PV glass. Obviously, we're going to be incorporating the recycled glass that we get from the recycling process into the glass. This is likely going to produce 30% less embodied carbon because of so many things, including the logistics, because glass today comes from China. All the rolled glass that we use in the US today comes from China or other places in Asia. And it's going to be powered by secondhand solar panels, as is our facility in Texas today. And obviously, we're going to have recycling right on site, right next door. So this is, our whole vision, like how to put this together and how to create the circular economy for and make it a reality. So this is where I'm going to stop and pause, and I'm going to ask if Kip has made it to has joined our call today or not. I'm not sure if he's online.
I don't see him on. We're going to be having more meetings too. So there's definitely an opportunity because financing is going to be a very important part of this discussion as well. So maybe you could talk a little bit because HG Ventures just invested in Solar Cycle.
Yep.
And before we get that, I've actually inherited 3 sets of silver utensils. I'm trying to convince my wife to recycle those, so trying to do my part. So
there you go. It's really a lot of silver in there too.
it is a lot of silver. But going back to HG Ventures, what was the conversation like that? And like, what are some of the considerations for financing as it stands now?
Yeah, so HG Ventures has been an incredible partner for us. As per the first bullet point, they've actually co-led this $30 million investment in Solar Cycle. Solar Cycle today is the biggest solar recycling company in the world in terms of investment. How much we've raised to date? We raised about 37 million. And HG Ventures has been, one of the big proponents and the big players that has helped us get to where we are today. And they still are, working with us daily. They're, part of our board, and it's extremely helpful. So the conversation around, the investment considerations for solar panels mainly rely around 2 things. Is there a market for this? Right? Will there be enough solar panels to make this happen? And then second is, will recycling take place? So for the first one is, how many panels are you going to be seeing coming to end of life? Is this, a huge market? Is this something that's going to take a while? Is it going to be 15 years into the future? Is it now? Is it 30 years into the future? And it goes back a little bit to that conversation that on that slide that I showed you, the different shades, how long those panels are going to last. The general assumption is, 25 to 35 years, because that's the warranty on the panels. Warranties are based on the power degradation, which is something that we know happens with panels, is expected. They're going to lose anywhere from 0.5 to 1% power every year, and that's normal, right? And 0.5 to 1 depends on how old the panels are. So it is expected that at some point they're going to cross the 80% power threshold. Okay, so if a panel has 500 watts rating, once they cross the 80% threshold, Once they're below that 400, then they're deemed end of life, right? They can still produce energy, but that's when end of life is considered to have happened. But that's not the only consideration. And that's where the 25 years breaks and becomes lower, right? Because when we take into account, like I said, weather damage, right? Hailstorms, fires, floods, hurricanes, those things all break panels and break a lot of panels, and that significantly lowers the lifetime. When we take in consideration transportation damage, that's early loss too. Installation damage, that's early loss too. Other sorts of power failures that are not related to the actual hardware, but the way that the energy travels in the solar panel. Additional considerations are repowering. The solar panels have gotten significantly more powerful over the last decade. And they've, by the way, gotten significantly cheaper over the last decade, right? So the cost of watt has decreased significantly. So all these things makes, a 35, something that could last very well 25 to 35 years, on average lasts much less. And all these reasons that I'm describing, what that ends up meaning is that we are seeing today way more end of life solar than we expected to see. When we started this company, we had projections that were already more aggressive than what is generally projected with this warranty. And even our projections were off. We're seeing more panels than we expected. It's significant demand. And this is all because of all the reasons I've outlined so far. So on the first question for investors, is there a market? The answer is absolutely yes. And that's why we've been seeing more and more competition show up and more people interested in this space. And that's the first consideration for investors. The second one is, will the panels be recycled or not? And here there are, a couple of things that can play a role, but one of the key things is also something I've mentioned before, the gap between landfilling and recycling. Today, it still costs more for us to recycle than to landfill. So if everybody wanted to do the cheapest possible option, nobody would recycle. And that's a problem because of everything we talked about, right? Everything that Karen talked about, but also everything that I've talked about. If we want to achieve net zero, if we want to be able to achieve circular economy, if we want to divert resources from landfill and be able to put them back into supply chain, if we want to be able to manage end of life properly and avoid all the community worries that the media is portraying. So on the second piece, this is where policy plays a role, because there is the question about can panels travel interstate in the U.S., for instance. It's not something that's easy to navigate. And if you have a high quality recycler in a different state, will your state allow the panels to go to that state, or would you rather go to a sham recycler, although you're not going to know it's a sham recycler unless you do the due diligence in your home state? Those are considerations that are super relevant when we're talking about policy. Is landfill allowed in your state? States in Australia, for instance, have already banned the landfilling of solar panels. And of course, if you do that only in one state and do that in isolation, then panels just cross borders and go to landfill in a different state. So it needs to be something coordinated. What are the prices of landfill in your state? That's also something that changes from state to state and will play a role. Is there any sort of EPR or any sort of product stewardship policy in place? Europe, Australia, US, Japan, they have very different structures and have very different requirements around end of life, and all those things, they play a role in whether panels are going to be recycled or not. So Kip and team at HEV, what they did is basically they looked at the business we were already in business when they came and invested in our Series A. They saw our processes. They did the due diligence around how much resources we were extracting, around the potential for us to be able to lower the cost of recycling, which is our whole idea. Back to one of the slides that I presented, they saw, okay, you guys are for real. You're doing this you really want to do this at scale, and you have good technology. And we definitely see the need for this. We definitely see the market requiring this. And those are the two things that needed to be put together so that investment could come in and help us do this.
So another question. So when we're reducing, reusing, and recycling, you're supposed to reuse before recycle.
Right.
You mentioned that these panels still have 80% capacity, and then that has issues with the warranty, if I heard that correctly. Has Solar Cycle considered getting into the reuse business as maybe a potential revenue stream?
Yeah, it's not that they have issues with the warranty. The warranty is actually that's what triggers the warranty, right? So your warranty lasts until that's.
Oh, I see. Yeah.
If let's put it this way, if you have a 10-year-old panel and that panel is producing less than 80% of your rating, then you can claim a warranty and get a panel back. If it's after the 25 years, the 35 years, whatever the number the manufacturer gives you, that's when and that power drops, then you don't have the warranty anymore. That's basically how it works. But back to your question, have we got into the reuse business? Yeah, so precisely the secondhand light farm that I've shown you in the picture is where we go and get into the reuse business. The issue with reuse today is there's a big difference between a panel being reusable and being resoldable, right? So reusability versus resellability, if you will. What we've observed is that there's a big market in the US today to buy reused panels to send them overseas. And once the panels go overseas, there's a lot of problems around that because you don't have the same infrastructure for recycling, you don't have the same oversight around environmental regulations. And we've seen this play out with e-waste around the digital divide. So these panels end up going to mainly Latin America and countries in Africa. And this lack of oversight has its own issues that come with it. So we don't want to be part of that unless we can put the infrastructure in place in those countries. And that's something we aim to do in the future. But as of now, the best way to reuse the panels is to reuse them domestically. It's hard to sell the panels domestically because the cost of a new panel has dropped so dramatically and the power industry has gone up so dramatically that an old panel doesn't have the same appeal as a new one. So there are applications for reused panels here. There are some industries that do reuse. We do reuse. We do sell panels for the reuse markets. But the way that we see to do that more sustainably is to not only keep them domestically, but also do it ourselves so that we ensure that they're going to be recycled at the end of life.
Got it. Understood. Any other questions from the audience?
Yeah, this is Scott from Clean Capital. This may be a better question really for your colleague, Nick, who I realize is probably not on, but can you speak, I guess, a little to your experience in Washington and California? We were having a lot of conversations here around extended producer responsibility, which a lot of folks don't like, but would like your sort of take on that, and then sort of how you view the policy constructs for customer-owned versus non-customer-owned modules.
Sure. Yeah, I actually have, let me go a few slides in the future. There you go. So EPR is there has been success cases and non-success cases. So in the US, it's a bit tricky when we talk on a state-by-state situation. One of the key things I think is to keep whatever policy is in place flexible. We've been seeing technology change a lot, and rapid technology change incurs in different kind of policies that you want to put around a product like solar panels. As an example of that, I have the lead content there because Karen was speaking to this as well, like the contamination from a solar panel. A lot of panels today, they don't have lead anymore. There are a lot of manufacturers that make lead-free solar panels. So if we have policies around considerations around EPR and management of those panels for only because of the lead content or only because of potential hazardous content, and we have non-lead panels, and that becomes the norm, in 2-3 years, we need to be able to flexibly adapt to that. The other one is, there's a wide range of solar panels, and the different sectors need different solutions. And this is especially true when we talk about household versus utility, which is something that I think you're interested in, Scott. It's very hard to do the bulk reverse logistics in household, right? Because obviously households, they hold 10 solar panels on the roof, and utility holds hundreds of thousands. So when it comes to reverse logistics, the industry today has been setting up really well to be able to handle the utility scale, but it's harder to do so on the household. So I can see, a policy, for instance, around an EPR exclusively for household as more inviting, more manageable than if we just do a blanket EPR across all those types of solar panels. Again, because the utility is more concentrated, it's easier for the companies to have one single stakeholder to deal with it, one single party to have to contract and recycling, and also companies like SolarCycle to come in and do the whole project, as opposed to having to collect in bulk, which makes the cost much, much higher. Also, when we talk about policy and we talk about the potential EPR, we need to make sure that we're not going against what's already working, right? So there's a lot of recycling already taking place. It's been amazing, honestly, amazing, more so than we ever thought it would be. How much the asset owners, the stakeholders actually own the solar panels and have to make a decision at end of life about what to do with them, have been stepping up to the plate and going with recycling instead of landfilling, right? It's more costly than landfilling, but they've been stepping up and doing the right thing and going with players like SolarCycle. So whatever's put in place, it's important for it to work, in favor of those existing relationships, in favor of things that are already working, as opposed to against them. And then there's a big consideration here around costs and quality. I think we need to set a very high bar when it comes to the quality, because like I said, the easiest thing you can do today is open up a solar recycling shop that basically takes the aluminum frames out. Okay, you can get basically 40% of the value, 40% of the actual revenue you can make from the panels is the aluminum frame. It's easy to pop those frames out. You can do it manually. You can have, a couple of people there and do it manually. You can have tools to do it, but then you just landfill the rest, and you can say that's recycling, right? The problem with that is twofold. One is you're really not recovering over 50% of the value, which is those precious metals that we talked about, right? So the silver, the silicon, the copper, which is the hardest thing to get. And the other thing is that if you just take the aluminum out and you dump the rest, you're basically dumping 90% of the weight of the solar panel. So if you just go for cost and you try to make everybody compete and just go for the cheapest possible cost, everybody's going to do this. This is the cheapest thing you can do. You can get some money up front. You can get the money from the aluminum, and then you pay very little to land for the rest. And this has happened in many different places, including Australia, where I've worked for a very long time. So policy considerations need to be able to set a high bar when it comes to value recovery to ensure we're not just doing, take the best and dump the rest approach. And then the last policy consideration I would say is low cost solar is key to set goals. And when I talk about low cost solar is, the actual program needs to be low cost. Because as we've seen already, there is already a gap between landfilling and recycling today. And if we put a program in that it adds even more cost and it's more onerous to the asset owners, that's just going to increase even more the cost of recycling. So whatever we put in place needs to be cheap, and it cannot be something that increases even more that gap that already exists.
I think David Comans had a question.
Thank you, Pablo. What percentage of panels are actually reused? I know you set up a reuse for your facility. The basis of my question is, if a large percentage of solar modules can be reused, is there a method to go recertify panels such that there would be belief that they would last 5, 10, 15 years, as opposed to simply saying it works now, put it out in the field and get what you can out of it? Because that would go into who is setting up a market for reused panels.
Yep. David, that's an amazing question. The answer is that there's no certification for that yet. There's no actual label that you can put on it and say it's going to last for however many years. There's a few reasons for that, but one of the key reasons is there's very little studies around secondhand panels. There's, our knowledge around panel reliability when panels are manufactured is incredible. Like the amount of scientists in industries working on this is really mind-blowing. But on a secondhand pieces, there's not many studies around reliability for us to be able to create a certificate around it. There are some efforts ongoing for that. There are some things that have started already, but we're still very in the early stages of that challenge. One of the key issues there is second life panels is actually a world of panels, right? Have these panels just, degraded in the field? Have they gone through LID? Have they gone through a hailstorm? Have they gone through a flood? Each scenario and each history of a panel is going to present itself with its own reliability issues that need to be tested for. So it's not something as simple as, well, not that reliability today is simple, but it's even harder than what the current state of affairs is with the first life of solar panels is. And just to make sure that I answer your question fully, The amount of solar that can be reused is not insignificant. I can't give you a number because this varies very dynamically. There has just been a massive hailstorm in the USA that basically, damaged millions of panels. Because of that, the ratio is very slow, very small for reused panels right now in comparison to recycled panels that need to be recycled. But it's not insignificant. I'll throw a number out there just for the sake of giving you guys an order of magnitude. I'd say like anywhere from 15 to 25% of the panels should be reusable today.
Thank you.
All right, any other questions from the audience? Cool. Well, if you want to stick around for, this is a nice segue into our policy discussion. If you want to stick around, and if Karen's still on, we'd be happy to have her as well. So at our last meeting, we discussed different policy proposals. And we can get before our next meeting, I can send this out. But at this point, we're really just trying to get some ideas on paper, and then hopefully we can finalize this conversation next week. And then again, we'll have even more chances to finalize these recommendations by October of next year, which is when the recommendation would be presented to the MTCC commission. So I will zoom in just a little bit. So just to refresh people's memory, there's two sets of recommendations that we need to put into this report. So examine and recommend infrastructure needed to develop a practical, effective, and cost-efficient method for collecting and transporting end-of-life solar photovoltaic modules for reuse, refurbishment, recycling, or disposal. Really, we should just take disposal out of that when we're thinking about this. And then the second set, it's based off of 9 in the law, but recommend financing mechanisms analyzed under item 9 right here of this subsection that best support a circular economy approach. So what I did is I mined our notes from our last meeting, which should be posted online, on some of the different things that we talked about in our last meeting. And then we can start from there. And then at our next meeting, we can actually talk about the language that would go into our report. So we talked about landfill bans. We heard a little bit about landfill bans, but it needs to be done regionally, or else they're just going to go out of state. That was this comment from our last meeting. Needs to be paired with other policy, and there needs to be an infrastructure in place, because if you just have the ban in place, then and there's no infrastructure to support it, it's just going to go all to disposal, or potentially outside the US as well. So the policies, the landfill ban, these are some of the considerations that we would need to consider to make it more effective. So opening it up to the team, is this something that we would want to put into a report as a potential, or as a recommendation? What are some folks' thoughts on that? And is there some more context that we need to add to this as well? Both of Davids raised their hand. We'll see who's first. David Bugelman.
Thanks, Bradley. Again, I'm here more for the utility scale perspective. And I think if you look at PPRP's conditions, there basically is a landfill ban for any CPCN level project. but that's actually not why I raised my hand. I guess thinking about, residential rooftop and smaller type projects, I mean, a landfill ban, that's one thing, but what about like, I don't know if this is a concept that exists in other contexts, but like waste diversion, like something so, you can identify if somebody tries to throw away a rooftop solar array, the county collections people will know what to do with it. Some kind of education to divert it to a recycling company that may be out of state. It's really sort of outside of my expertise, but I'm just wondering, is there a way to sort of fit into what happens when, like a small business or a homeowner throws something like that away, and sort of making sure it doesn't end up in a landfill, or if there's potential for it to end up somewhere else, as opposed to just an outright ban?
Yeah, that's an excellent question, and that would be the that could potentially be the recommendation, and the recommendation could be explore the feasibility for whatever you just said, or require county to since recycling is mostly done at the county level, or they'd be doing the pickup.
And again, this is showing this is outside of my area, but
Right.
like what I'm thinking of, I live in Anne Arundel County, right? So I had a bunch of paint, and I looked on the county website, and there was like a biannual paint collection drive. So I drove and I went there as opposed to doing something else with the paint. So maybe there's a way to, obviously this would be different, but some kind of program to educate people and help them bring this stuff to the right place.
Which just had a meeting on this, but and we talked a little bit about this last time, that Maryland is actually going to be implementing a program called Paint Care, where you pay a fee up front, and then and then the industry set up a nonprofit which handles all of the end of life management, and they're going to be providing free pickups at paint retailers. Now we heard solar panels last for 30 years, so there may be some around 30 years, so there might not be as comparable of a model, but that's something.
Yeah, I think you've heard a lot of pushback about extended producer responsibility in the solar context.
Mhm.
One thing that comes to mind with solar that's different than paint or other goods is that, the state's trying to incentivize people to install these systems. You have like a rooftop installer, you have a residential homeowner looking at these systems. I think it's important to be careful. There's all these programs to give grants, and there's all these incentives and things like that. And then you're sort of going the opposite direction if you're imposing a fee that ultimately those, whether it's the installer or directly, from the homeowner, they're going to end up paying for it eventually, right? So I think that's an important thing to keep in mind. But the idea of some kind of program to make sure this goes to the right place, maybe it's state funded, maybe it's county funded. Again, the example I was talking about, that's before, with paint, before the state's implemented any kind of responsibility for producers to fund that, right? So, and it worked, at least for me. So, maybe there's a way to take what works without burdening the industry when we're trying to aggressively incentivize these systems.
Yeah. I see, Scott, you had your hand raised.
Yeah. Didn't you have the other David though first?
Oh yeah. Dave, I didn't see his hand in the queue anymore, but Dave Comas.
Right. Addressing your landfill ban, you keep talking about shipments out of state. I'm not sure that's a big issue as long as it goes to another state with a landfill ban. And in fact, you probably don't want to put a landfill ban in place until there is a solar recycler within the region, not necessarily within the state, within the region, that can in fact recycle to whatever standard you want to. That addresses Pablo's idea of the sham recyclers. There has to be recycler that meets XYZ standard within the region, and you can send them anywhere within the region, but you can't send to a state that doesn't have a landfill ban. It's got to go to a recycler.
So I'll add to the note on that. This is either regionally or an MD.
Yep.
I mean, obviously we love jobs in Maryland, but all right, Scott.
Yeah, so I think on that note, I mean, I think Clean Capital is more comfortable with a gradual sort of landfill ban, but I think to sort of Dave's point, needing sort of a viable option before you go to that route. And I think, I guess it would even be more complicated if you're trying to put, sort of strings attached around what states you could, in theory, send out. And I think you're going to run into Commerce Clause issues. So I think we need to be sort of mindful of how you go about trying to do a ban. And I really think the only thing you could do is say you can't landfill within the state of Maryland. But again, I wouldn't recommend that until there are viable options. I guess I'd be a little bit more opposed to trying to say, you can only, export your end of life materials to certain states, because I think we don't yet have an infrastructure in place either to guarantee what states would have the recycling capabilities. So even if you were trying to say you're only exporting to states that also have a landfill ban, I think that's going to be a bit complicated. The other thing, though, I guess I wanted to flag is two things. One, sort of the importance of encouraging actual incentives for bringing recycling facilities into Maryland. Obviously, we can't control whether or not we encourage facilities more on the East Coast, but I think what we've heard today is that the vast majority of end-of-life panels that will be coming to end-of-life soon are really more on the West Coast. And so because Maryland is not a booming utility scale market relative to the rest of the nation, it may be difficult to get more sort of facilities opened up within Maryland or adjacent to Maryland. And then my final thing I flagged in a note, but interestingly, the Washington Department of Ecology is sort of recommending that Washington walk back part of its extended producer responsibility law because manufacturers are not going to comply with it. And so I think it's worth looking at that as an example of what not to file, as opposed to what to file, which was sort of some of the thinking from some members of this group on the last call. So I'll sort of end with that.
I thought it wasn't that they weren't going to comply with it. They just weren't going to sell in the state of Washington.
That's effectively the same thing, because it would then result in increased costs and a burden to the industry.
Yeah. All right. Pablo?
A few comments on what's being said. So I think it's important to point out that many recyclers that I know of today do service the whole United States, right? Not just the states you're in. So obviously I can point to SolarCycle because that's the one I know the best, but we serve all the states in the USA. So if there were panels that needed to be recycled in Maryland, and we've worked already with Northeast USA, we can recycle those in our facilities. Main reason why we're in Texas is because of the concentration of solar, which is something Scott just mentioned. It's not because of anything else. It's really just where solar is, and we chose a place where it's concentrated. And then in terms of landfill ban, I think I have two comments. One is the idea of just increasing the cost of landfilling is an opportunity. It's something that can be done, such that you make it harder to landfill, but also if you need to send it across state borders to landfill, that's an additional cost on itself just to send it across state borders. So that automatically, you capture that side of the equation. And then obviously, if you guys do think about doing a landfill ban, one of the ways to do it is to announce it in the future, right? So say by 2027, I don't know, I'm just making up a date, we will impose a landfill ban, which allows then the market to work its way around that and know that that's coming. So just a few comments and thoughts around what's being discussed.
A delayed start.
Yeah, exactly.
Some good thoughts there. I thought I saw another hand, but if not, we can move on to the next.
Yeah, no,
item.
I briefly popped mine up to respond to Scott's comment about manufacturers not complying and highlight that it was they were deciding not to sell into Washington State, which was completely, going against the state's clean energy goals. And it's because it's not economical to do so. It would kill the solar industry there. And then the second point, on incentivizing in-state recycling, Pablo highlighted this, but part of the reason we co-locate our recycling facilities with our manufacturing facilities is to ensure, a more steady flow of materials. If you, invest in a recycling facility and it has nothing to recycle, or recycles 1 month and nothing the next, it's not going to survive.
I have another question for Karen. So you're vertically integrated, so you're servicing your own solar panels. But if you have a surplus of materials, which may not be a problem, would you sell to other solar recyclers?
We absolutely can sign recycling service agreements with other recyclers. They're welcome to send panels to us for recycling. We've designed our recycling facility capacity so we currently have a global designed recycling capacity of 3 million solar modules, more than 110,000 metric tons of solar modules, and it's purposely designed to be more than any potential manufacturing scrap, so that way we're able to take modules back from the field. But it's also not, operating at maximum capacity because we're not yet seeing those high volumes come back yet. And that's more expected beyond 2030.
Yeah, thank you. Dave Comas. David.
As a reminder, the students at the students that I was working with did take a look at where solar panels will be coming of age in the region, and they decided that North Carolina is by far the next location where there's going to be a peak, and then Maryland, and then Virginia. So it is more than likely that if the laws, either tax or energy or hazardous materials, are pointing, somebody's going to be looking in that region rather than Maryland, which was why I was talking about a regional. It keeps the transportation costs lower than sending it all the way to Texas or all the way to Alabama or whatever. With reference to Pablo's comment about 2027, I know that was just a throwaway date. But one of the things we were looking at is when would we expect to see the peak for this region, and the answer was 2035. So I think we have a little bit more time for this ban than you would do it. So maybe 2033, not necessarily 2027. It's not that close of an issue. So if we could have time to go do the policy and the financing, the budgeting, the inducements, and get time for somebody to build something before we're there. That's all I had to say.
And I think the UMD and Johns Hopkins are refining that, and so that can help inform like when that date is as well. Nick.
Yeah, so thank you. I just want to say, first of all, thank you for doing this and making it open. I'm with Solar Cycle as well, and I work with Pablo very closely. And, I think you're, first of all, doing the right thing here by asking some questions and having this working group. I just want to share a couple things that we learned from working pretty closely with Washington State, because I know we brought this up a couple times on the call already. So, and this kind of tags onto what David Comas was just saying. So the first thing to understand is that unless there's a fair amount, and this really picks up what Karen was saying too, right? Unless there's a fair amount of volume of end-of-life modules, I think any program is going to kind of struggle, and in-state recycling is not going to be economically viable with current approaches. So we are also very supportive of a regional approach, right, with a set of I mean, our corporate approach is to develop a set of recycling facilities that have a lot of technology, that require a lot of capital to set up, and are highly efficient, highly effective, and very safe. We did examine, like we worked with Washington State and some of the stakeholders there to think about what kind of take back program would be most effective. And one thing we found is that the volumes that Washington was going to expect in the next 5 years would basically be equivalent to like 1 truckload per year, 1 to 2 truckloads per year of end of life crystalline modules, at least. And so it's just, I think you just need to scale any policy to kind of think about your local challenge, which of course is, I know the point of this working group. I think that a hybrid policy, I know maybe Pablo talked about some of these ideas before I was able to jump on. I'm sorry, I'm just tacking between different calls. A hybrid policy that provides some collection points for the small volumes of kind of, residential, small commercial systems that you're likely to see in the next 5 years would be helpful. So kind of like a household hazardous waste drop off. I think the other thing that would be great for Maryland to do, especially before a lot of large systems are installed, is to put some recycling requirements into the permitting requirements for larger systems. Maybe that's over 1 megawatt or 500 kW ground mounted systems or large rooftop systems. I think if you just include in your permit requirements a stipulation that asset owners should have a plan to recycle the modules if they're broken during operation or when they repower, I think that's going to do a lot to create the right incentives for people to start thinking about that stuff.
And so you didn't see our presentation. We actually had someone from PPRP, or it's the PPRP program. I forget what it stands for exactly, but it's for systems that are 2 megawatts and above, and there's bonding requirements to pay for that, and then there's also you have to submit a decommissioning plan, which gets approved by the state as well.
Got it. And Bradley, I'm sorry I'm sorry I missed the earlier presentation. I'm still coming up to speed on what you're all doing here. Do the decommissioning plans require recycling, or is it just site removal?
That I would have to let someone answer. But David, maybe you can expand on that.
Yeah, I've worked with a ton of developers complying with those requirements, and they do require recycling. One sort of attribute is the state has allowed the cost of decommissioning to be offset by projected resale value. And kind of looking further down on Bradley's outline here, one of the points is incentives for reuse. I view that as an incentive for reuse because basically what it says is you show us that you found a way to resell these panels. The way the plans work is they're basically approved every 5 years. So it's looking out in the next 5 years. It's literally looking at, like, we have a utility scale project that's 2 years old. For some reason, we have to remove everything and resell the panels, which I think is realistic to then look at, okay, what's the resale value? Then you can incorporate that into your cost estimate and then decrease, or in some cases, almost completely eliminate the bond. So that's just one sort of way this stuff factors in. But basically, there needs to be a plan in place for recycling and reuse. They include estimates for transportation costs and like the actual cost of removal. So pretty comprehensive.
Yeah. And then we'll get to this, but I think the third bullet is to provide incentives for donation as well to overburdened and underserved communities. We are jumping around a little bit, which is fine. But yeah, there's definitely some things that we can do to encourage reuse.
Yeah, I mean, I just jump in to say about reuse, and Pablo can talk more about this if he's still on the call. We actually published a blog post I can put in the chat. And, what we found is that other recyclers who touted reuse programs have pretty much stopped doing them because the value of the secondary panels has fallen quite a bit. New panels are so cheap, so powerful that the reuse market is not big. So it's fine to kind of talk at a legislative intent level of wanting to allow asset owners to reuse and encouraging that. But I think you have to leave it to the asset owners and the recyclers to decide, like, is this panel in good enough condition to reuse? Is the juice worth the squeeze in terms of the, transportation, testing, certification, resale, things like that? I think it's certainly reasonable to include potential valuation of panels, secondary valuation in a recycling plan, right? As like a salvage figure. And I know we've talked with some asset owners who like the idea, obviously, because they're asset owners, of having a graduated bonding requirement. So in other words, when they're installing the panels, they have to put up a bond worth, 5% of the system value. And then when during operation and maintenance, it's 25, it's 20. And then, 5 years in or 10 years in, when they're, decommissioning is more likely, it's the remaining, 75%. And that ensures that the state has a bankruptcy proof kind of financial assurance mechanism that can be tapped if a project gets damaged or if a project needs to be decommissioned. But that also is allowing asset owners to not have to put, $20 million in an escrow account or something like that. So I think there's some interesting stuff that's being developed in that way that allows, those costs to be fairly shared.
Yeah, we actually had someone who provided used panels for concerts and would move them around to different venues. And that one thing that came up is if you're going to go into the reuse market, the requirements for like electrical use and like it's not zoning, but what am I thinking of? They might not meet the same standards, and since he wasn't providing them on a fixed structure, he wasn't necessarily subject to those same requirements. So he was able to utilize that.
And I mean, just to jump in, I mean, I will say we're certainly not against it. So we did reuse about 500 kW worth of panels on our own recycling site, and we were able to kind of cherry pick the panels that were in the best shape and in the best output. So, and then we also know that if these panels fail prematurely, we've got the recycling lines are right there, right? So we don't have to then worry, are we selling them to a developing world or market, right, where they're not going to be recycled safely. So that was, and I put the blog that Pablo wrote in the chat.
Cool. All right. So incentives to bring solar panel recycling to MD or regionally. I know that we had, and maybe they're Senator Benjamin Brooks and Delegate Mike Rogers on. If there were to be incentives, I guess, has anyone seen regional efforts for providing incentives to bring industry to a certain region? Is that something that, and what would those incentives look like?
I mean, I'm not aware of any specifically, but I don't know if we've checked with like NCSL because they sort of capture data by state, sort of who's doing what, and they may have some pretty good lessons learned with respect to what some other states are doing, particularly in the Northeast region.
And NCSL is
I'm sorry, alphabet soup. I'm a military guy, so we're full of acronyms. National Council of State Legislators.
already 10-4.
I think one thing I would just say is DOE has offered some regional incentives for things like hydrogen hubs. I don't think they've done that for PV, but it would be an interesting way to kind of, do some development around that. But You got a cap and trade program too, right?
Yeah. There is a regional cap and trade program. Maybe something to think about for that. All right. So there's a comment, the New Jersey Recycling Commission report recommends incentives, but they didn't actually implement any. I see. Okay. Okay, so we had Siri come and give us a presentation. What are some folks' thoughts about requiring, if you are going to have end of life, to require something like R2? It doesn't have to be R2, but that's the most common one, certification. Karen?
So I actually spoke with Siri not too long ago, and they mentioned that currently there are no PV recyclers that are R2 certified. So I think that's important to keep in mind. But it is, I think it's an important certification. I would, for manufacturers at least, also recommend including EPEAT if you're going to include certifications and eco labels. So they require, they have some requirements around recycling, material, some leadership criteria around recovering materials and so on, and ensuring that the recycling is done responsibly.
Now, would
And
that
not
also,
just recovering the frame, like Pablo highlighted.
now would that include post-consumer recyclability as well? So it not only does it have to be responsibly recycled, but you have to have, let's say, 30% of your panel by weight or by volume have to be recycled as well, or use recycled materials.
They do. So they do have recycled content criteria. Currently, those are leadership or optional criteria. So the way EPEAT works is to achieve bronze, you have to meet all required criteria. To achieve silver or gold, you have to also meet the leadership optional criteria. And one of the challenges is because solar modules have a long lifetime, it's going to take a while for those materials to come back into new solar panels. So that's something to keep in mind. But that is, a big focus for high value recyclers to really close the loop and bring things back into the solar industry, because that's the greatest value. But also, to answer your question, they do have, percentages encourage to encourage recycled content in solar modules.
Got it. All right. So going to be Scott and then Nick.
Yeah, so I was just going to say the only thing that I guess you should keep in mind if we think about certifications is, so I think EPEAT is only for solar, correct me if I'm wrong, for solar, but there's also now a bunch of different certifications between sort of this EPEAT, this R2 one. We learned about SIA is in the process of the ANSI sort of, standards for SIA 601, SIA 602, SIA 603. So I just think we need to be very careful about, if we are going to require certifications, that we're very clear about the multitude of certifications that could be utilized, so that we're not unintentionally requiring only for solar.
Yes.
Or what type of module.
And typically when these certifications, because I was just looking at this and for another law, they list multiple certifications, and as long as you're using one of those, then you'll be fine. Or it would point to a certification that uses an ASTM standard or something like that. Scott? Oh, I think that was your comment. Nick?
Yeah, that was me.
Yeah, I mean, Pablo's far more expert on this, and he just put a thought in the chat here. But what I would say is that, this kind of goes with, with this comment, right? Is we want standards that encourage high value recycling. So that means recycling of the semiconductors. At the same time, the R2 standard right now doesn't really require that. My understanding from reading it is it's more about the quality of the output streams, which of course is important. Our approach is to certify with ISO for quality, environmental performance or management, and occupational health and safety. And then we reached, I think, a 93% or 95% mass, or 95% value, I guess, and 90+% mass standard. So, but I think it is important to have some kind of standard and threshold in there, and that, to encourage high value recycling and not just shredding of the modules and selling to the lowest use.
Yeah. Karen?
Yeah, sorry. I just wanted to respond to Scott's point. This wasn't, to only require for solar. There's also Q cells that have registered to EPEAT. But, it's important to recognize EPEAT is globally recognized and the only solar eco-label and standard recognized by the US EPA for public procurement. So it's not a random eco-label to recommend. And it does go to what Nick was just talking about, quality recycling.
Yeah. And someone actually just sent me a chat on that. So it's there's definitely a lot out there. So the next one was establishing a stewardship organization, typically through a nonprofit. At a last meeting, we talked about potentially having this for the residential side only, because in Maryland there's already a pretty robust, going back to the PTRP rules that we already have in place. What are some folks' thoughts on that from the perspective of for it being residential? And we actually did meet with some of the some folks who represented residential solar, and I think we invited them to this meeting as well. But Scott?
I was gonna, Nick, I don't want to put you on the spot. I wanted to ask you, because I know we were talking a little bit about how some states like California are considering differentiating sort of the customer owned versus non-customer owned with this piece. I think from my standpoint, it may make sense to do that. And I know there's been some robust conversations around, whether there's an advanced, recovery fee or some sort of fee exclusively for customer owned relative to non-customer owned. So if there's anything you can lend on that, I think it'd be helpful, just because I have less experience in that conversation.
Yeah, I mean, I would say this is something that we're talking about in Minnesota and in California, right? And to go to Brad's initial question, it's a way of kind of splitting the market a little bit and creating a system that can work for residential, right? Whether it's advanced fee or drop-off fee, and coordinate the residential pickup and creation of drop-off points. And then our preference is to allow for the bigger projects, right, depending on how that's defined in Maryland law, to require them to have an agreement with the recycler, and then we can work directly with the asset owner. So that's our preference, is if you're going to have a PSO, to have it focus on the residential and smaller markets where the coordination is more important, and then do the larger systems through the permit driven recycling, basically.
Yeah, I just, throughout these conversations, it sounds like the need is definitely more on the residential side. So we talked a little bit about providing an incentive to incentivize reuse. I'm going to put reuse / donation right here as well. But then we've also heard that solar panels are becoming so competitive new, and they're better and provide more output, that the reuse market is really relatively small. Any thoughts on this? Karen?
I would be very careful about providing incentives for donations where you're essentially making the waste someone else's problem. You know, the cost is in the recycling and the treating the panels, and so I don't quite understand this one.
So from this, where this came from, and we've had a lot of discussion that we need to try and reuse before we recycle, especially if panels still have 80% of their capacity. So that's more where this is coming from.
Yeah, I mean, I could share a few high level thoughts. I mean, Pablo's really written a bunch of papers on this and wrote this blog post. But I mean, our take is that it's fine at a legislative intent, or to say, hey, the state wants to encourage this. I think what we would probably want to avoid is mandates. I mean, California had this kind of very strong language, and it's SIA and a lot of industry groups pushed back and just said, look, what if you have panels that are damaged? What if you have panels that, look okay, but just aren't producing? And this is the type of decision that should be left to, asset owners and recyclers. Like, hey, if we take off, a megawatt of these panels, we can evaluate, can they be reused someplace safely? Can they be resold? Or should they be recycled? Is really that the highest and best use? What I would say too is that from working a lot with folks who are steeped in the EPR frameworks, that reuse before recycling is an important concept in EPR. I just think it doesn't always apply to solar, from what I've been learning. I don't know if Pablo has other thoughts.
Yeah, I agree. And I in my presentation, I did talk about the reuse case and how we're seeing the market opportunity mainly overseas for export, which is something that we believe we should avoid for many reasons. Team, I do have a call coming in at the top of the hour, so I'm going to drop. I appreciate you guys, putting this on focus and being one of the topics of discussion. I appreciate the opportunity to come over here and talk to you.
Yeah. And just so we've had a lot of conversation. We're at our next meeting, we're going to be talking about this again. But is there any? We're going to open it up to the public now.
I can stick around for until.
Bradley, I'm gonna have to jump in a few as well for another meet, but I'll hang on for a couple more minutes.
All right, hearing nothing from the public. Thanks so much for joining this meeting. Based on the conversation, I'll take a look at the notes. I'll try and get folks some draft language for recommendations with some of these considerations by our next meeting, which is next Thursday. And then we have another one after that. And again, we're going to get a second bite at the apple, so we don't have to have everything finalized by next Thursday. And we can certainly take a look at a phased approach. And we make recommendations to the NCCC every year. So, all right.
Thank you so much. Appreciate the opportunity.
Thank you.
All right. Thank you. Talk to y'all later.
Thanks a lot.